Okay, let's get started. Okay, to be honest, I don't know if that was funny at all, but I was so proud of myself that I managed to get it to work that I decided to leave it in. But this video isn't about me learning how to use OBS. This video is about Sound Studio 2024. Wait, I have something for this too. Hold on. Sound Studio 2024. So, hello, welcome. If you're watching this video, you are probably one of two kinds of people, either a student in the course, in which case, welcome. I'm excited to meet you in person tomorrow, I think. Or you're just checking out this material through YouTube or because you're interested in Macs or something like that, in which case also, hello. So yeah, this spring we'll be doing a course, Sound Studio, talking about sound design, interaction design, talking a lot about Macs and Rainbow and things adjacent to those topics. More on that in a second, but I'll just say that, yeah, I thought it would be cool to, so if you're a student in the class, I'll do my best to put all the lecture material online so that you can watch it at your leisure, so you can go over things or just refresh yourself if you like. And though obviously in class it'll be more interactive, we'll be able to go into things in depth and talk about whatever might be interesting to you. And if you're just following along online, then I don't think there's anything special to say except welcome. And I hope it's useful to see some of this material online, especially the kind of bits about Macs and Rainbow that are new in the past few years. So what is this course about? I think that the core of this class is really going to be about interaction. Obviously, it's a course about sound. But I think what makes it different from a class that might be about, we will talk about sound design, composition technique, about production and things like that. But all of it will, I think the focus and the emphasis will be on interaction and how you can interact, design for systems that are interactive and how you can interact with a sound making system. And I think there's sort of two things about that that are particularly interesting. One is interaction with respect to tools that you make yourself for your own use. We'll look at some examples of places where people have made, for their own use, tools for sound design that I think enable them to make really original work. And I think that folding interaction design and development of your own tools into your either design practice or your art practice, the emergency services don't want you to design your own tools, but you don't need to listen to them. You should go ahead and do it because I think it's a way to make really original and interesting art. And then the other place in which we'll focus on interaction design is in the context of designing for either art pieces or design pieces that intend to be interacted with by their audience. And that could be, maybe you're designing a tool that somebody would use as a sound designer, so a VST or some kind of audio plugin, or maybe you're making an art piece, either an installation or an online work that has an interactive component, and where interacting with that system is itself part of what you design for and how you intend for somebody to explore and get to know the system better. And the tools that we'll be using lend themselves really well to incorporating and thinking about the interactive component of what you're doing as you build systems that have some kind of sound design, interactive sound aspect to them. So that's, I think, what sets this class apart a little bit from other classes that might be similar to it. So let me switch now to look at that, incredible. He really does know how to use OBS. So all the course notes will be available online publicly in this GitHub repository. That's both if you're an NYU student or if you're not an NYU student. If you like, you can just, some people I saw were familiar with Git, but not so familiar with Macs. Others familiar with Macs, but not so familiar with Git. In this first class, and maybe for the first other couple classes, I'll just kind of assume that everyone is more or less, or I'll just assume no knowledge, and we'll move quickly through the kind of introductory parts. But if you want to get the course notes, you can just come over here to where it says code, click this and hit download zip. It's fine to do it this way. The only thing is that I'll be making changes, adding and removing notes throughout the semester. And if you want to get those changes, you'd have to download the whole thing again if you use this download zip button. Better is probably to clone the repository. If you're familiar with Git and GitHub, I won't cover how to do that from the command line, but there are very useful tools like GitHub Desktop that basically just let you use Git as if it were Dropbox or for version control, that kind of thing. So you can just hit clone a repository from the internet and paste in the URL of this, of the course notes, and then clone. And once it's cloned, show in Finder or show in Explorer, and you can see all of the material for this course that I've made so far. And the reason that it's nice to do this way is if I come to, say I go to the my local copy of the notes and I change hello, welcome to the very first class to hello, welcome to the, I change first to first, and then go git commit am numerical language. Then you'll see here in GitHub Desktop, well actually you have to fetch first just to make sure that you know, to sync this local branch with what's, or the local history with the remote history, and then you hit pull origin and you'll get all those changes. So it's a good way to keep your local copy of the lecture notes synced up with whatever happens, whatever changes I make through the semester. I would say one small caveat is it's probably a good idea not to spend too much time modifying the files or adding or removing files to what's in this folder. If you want to create your own patches or your own notes, I would put those in a different folder, only because if I change something and then you try to pull those changes, there might be a merge conflict. It's not a big deal if that happens, just get in touch and we'll sort it out. But yeah, you could think about this folder as being basically read-only, and it's a way to make sure that you don't run into any issues with respect to merge conflicts or anything like that. If you're really comfortable with Git and you want to make a branch and rebase on my branch, or even, who knows, make a pull request, we can treat this class as being open source. It would actually be kind of cool. I've never done that before. It might be kind of fun. Anyway, up to you if you're really comfortable using these tools. So let me think about what other NYU specific stuff I wanted to cover. So in terms of the structure of this class, I will just say that the, in class we'll talk about techniques, talk about technologies, and we'll look at some art that people have made that uses those tools and technologies, but the bulk of the work and the bulk of the learning, no matter how well I present the material, the bulk of the learning really is going to happen on your own when you're making stuff. And I really do want to put an emphasis on this class in making things. Every class other than this first class will have 2 people come in and present something they're working on. And we'll cover a bit how to do a crit. To be honest, I don't have an art history background. I've never been in a class that had a crit before, but I hope we can develop a practice in this class that enables people to feel supported, enables us to talk about each other's work in a constructive way, and to build a kind of collective sense of our style and to help each other develop. Because I really do feel like, I know personally when I was learning Max and when I was learning to program and to start to make artwork, all the learning happens on your own. And I hope that we can cultivate a kind of, that we can all do that in this class, basically. And so with that in mind, I'll say that when it comes to following along with the Max programming that we do in class, I wouldn't, for the first class, you may want to follow along, especially if you're not very familiar with Max, if it's your first time seeing it. In later classes, the concepts are much more important. And the notes will always be available, the patches will be available if you want to go back and check those out. I'll say too that sometimes people ask me about Max, whether Max is the right tool for the job. I want to be in sound design, is Max cutting edge? Should I be learning Max? And I'll say about that it used to be that there really were only a handful of ways to do interactive sound. And now, there 1,000 flowers have bloomed between P5 Sound, Tone.js, Tidal Cycles, Bitwig, Ableton Live. I mean, the list goes on and on, different ways that you could do some of these things. And to be honest, on some level, they all kind of do the same thing. And the skills transfer between these different things. So your time is certainly not wasted learning Max. We'll cover a lot of sound design techniques and a lot of interaction design techniques that I think are not only really cool and really applicable, but also transfer to other domains too. And also, Max is a program that works really well with other systems. There's facilities in Max for sending MIDI to other applications, for sending OSC, Open Sound Control packets to other applications. Network communication is possible. Serial communication is possible. You can run it inside of Ableton Live through Max for Live. You can start node processes with a node.script object. I mean, it really is very, very flexible. And if you want to incorporate other applications and other practices, be they animation, sound design, whatever, into what you're doing in Max, it will be possible. So all this just to say that I think it's definitely worth exploring some of the things that Max can do in this class. So let me check quickly if there was something else that I'm missing. No, I think that's it. So let's now switch. So I've talked about Max a few times. I don't know if everyone's familiar, but basically Max is going to be the kind of workhorse for what we do in this class, especially in the beginning. Although I will say that I really do want this to be a self-directed class. And if you yourself are really, really interested in going out and exploring something specific, maybe building a VST, doing stuff in web audio, making a web audio module, or doing an installation design using Raspberry Pi or some other physical computing system, we can definitely go into that in depth. And the course can be flexible in that sense. But for the beginning, Max will be kind of the core for how we explore a bunch of different sort of techniques in working with sound. And also, it having just come out in the last 2 or 3 years, we'll be exploring Rainbow too. We'll talk more about what that does, but basically it's a tool that lets us take the work we do in Max and then export code that can run in the web as a VST on a Raspberry Pi or anywhere that you can compile the code. So it really is very flexible in that sense. But let's talk about Max and what the heck this thing even is. So Max is an astonishingly old piece of technology in some sense. It's more than 30 years old at this point, which is crazy. I mean, we're talking about technology, other pieces of software that are more than 30 years old. We're talking about Netscape Navigator, AOL, really a different era of programs. And in fact, some of the earliest versions of Max were very simple and really purposed. It was a point in time where, now I think hardware systems are very flexible, but this was a point in time where hardware and software were really developing in parallel. And any new step forward in terms of hardware, there would be custom software that went with it. Sort of even personal computers were even, not necessarily the norm if you were in an institutional context and you were working on the cutting edge with respect to, whatever field you were in, you might still be using like a larger mainframe or purpose-built computer, or not necessarily a personal computer or a more general purpose computer. All this to say that Max was developed here at IRCAM. This is IRCAM, this building over here on the left. On the right, this is the outside of the Centre Pompidou Museum in central Paris. And this is the Place Igor Stravinsky and the Fountain Igor Stravinsky, that in my lifetime has never actually worked. It's always been under construction or under repair, although I hear, I haven't been myself to confirm, but I hear that as of less than a year ago, this fountain is now working. So any Igor Stravinsky fountain fans out there, you waited a long time for this day, and now this day has finally come. But IRCAM, this building back here, it's a really cool place. I don't really know if we have an equivalent in the US. It's a federally funded research institute for music and music technology to develop musical culture around technological development. A really cool place. A lot of interesting technologies have come out of it. It's actually kind of wild. Big chunks of IRCAM are all underground under this fountain here. And you can see these big kind of tubes here. That's the ventilation for this sort of underground. It almost sounds like it's like DARPA or something, this secret underground research institution for sound. And if you look, it's a bad photo of the exterior that I wanted to show you for some reason. Some of the underground facilities there are really cool. This is a picture of the Espace Projection, and these panels in the wall can be rotated and adjusted. It's a concert hall. People go there to see concerts and make recordings and things like this. By adjusting the positioning of these panels in the wall, they can change the reverberance, the quality of the room, the way that sound reverbs and echoes in the space. So you can tell it's a place that cares very deeply about sound. What Max is, to go back to Max, it's a software developed at this institution whose purpose is to help composers and programmers work together. And unlike a lot of other music programming systems, especially of the time, I mean, you have to remember, not too many years before Max, when people wanted to do something like, write some computer music, get a computer to make some sound, there were people using punch cards. There were people who were writing custom code, and not, easy to write code, difficult code, assembly, actually telling the computer, move memory from this address to this address, add the numbers, store them in this register. Like that level of primitiveness with respect to programming languages, people were writing music this way. And so the developments in software at the time, people were really interested in figuring out ways to make that process feel a bit more like composition. Can we make working with a computer feel a bit more like working with an instrument, where you try something out, you hear how it sounds, and then maybe you incorporate that into your composition or something like that. So the big distinction between Max, there are two big distinctions between Max and other programming languages. Number one is that the environment does not compile. It's always running. Actually, parts of it compile, but we'll get there. It's always running. Any changes that you make, you hear what happens right away. Obviously, if you're in a creative process or a design process, that can be really, really useful. The other distinction, wait, I forgot it. Oh, it's that it's visual. Unlike text-based programming languages, you're not writing out lines of text. You are moving objects around, and by connecting those objects together, you can affect the behavior of the overall system. Give me 1 second. I didn't get any water, and my throat is killing me. I'm just going to get a glass of water. I'll be right back. Don't go anywhere. Okay, maybe I put a cut in there, maybe I didn't, depends on how lazy I felt like being. If I didn't put in a cut, thank you for your patience. If I did put in a cut, time travel, incredible. Let's see, where were we? Talking about Max, talking about EarCam. Okay, so the things that Max was enabling people to do, I'll show some examples of work. The things that Max was enabling people to do, it's kind of interesting. So there's a legacy of work, I think, that goes back very far. That what am I trying to say? I'm trying to say that this principle of incorporating interaction into composition has a long legacy and a really rich history, and I think a history that continues through to today. And it's one of the cool things about working with a piece of software that, while being 30 years old, or rather that while being very modern in some sense, also has a long history and a deep connection to a lot of developments in 20th century computer music. So this is actually one of the first things that got me really interested in computer music. It's a performance by Michel Weiswitz called The Hands, and these are custom-built controllers that he's using. Well, I'll show you the clip and then we can talk about it. Okay. I mean, it's wild to me how little has changed in some sense. Kind of looking at that video, there's just yeah, it's it's as it's always. You go to a concert. I feel like I was just at a concert. It looked the same. The cheap table, the computer sitting on the table, big synth monitor. Anyway, point is, I thought that video, he's got in that control, I think he's got, those are custom built controllers. There are buttons under each finger that can sense how much that finger is, how hard that button's being pushed down. Also, I think a field effect, a Hall effect sensor to see how far or how close the hands are. It might be done with that way, it might be done with radio, doesn't matter. But again, people were interested in doing this thing. This is from '93, and this is from, well, a few years ago, but I think Emotion Heap is still. I don't know what all this is.
To my house.
Okay, we'll skip around a bit.
Help me gesturally interact with my computer so that I can make music on the move in the flow and more humanly, more naturally engage with my computer software and technology. So here they are. This is the latest one. This is an earlier one, and these are many other iterations. What this glove enables me to do is access mappings inside my computer so that I don't have to go to mappings inside my computer so that I don't have to go to a keyboard or a fader or a button. I can use, say, a fader instead of doing this, which is not very expressive or exciting for me or the audience. I can do this. So I'm moving around the scale by going up and down there, it goes down a fifth, or down a fourth. And then I can change the filter like that, and I can go between different sounds by going up and down using the pitch. This is what we call pitch, this is what we call yaw, this is what we call roll. And here, filtering the sound and kind of pitch bending it. And then stopping our arpeggiator and starting it again. So these gloves have traditional bend sensors inside, and this measures this kind of movement. So this may be 0 and this may be 127. And we're also using these fourchettes in here to get that kind of that action as well. And when my finger is doing this posture, which is called one finger point,
okay, so I could
changes to a different sound.
I could just watch this video all day, but yeah, again, it's the technology has improved, and those gloves are so much more. There's so many more sensors and so much more. They're so much simpler, lighter weight, smaller than Michel Weiswitz's gloves. But the practice of trying to design interaction and to think about, I mean, she used the word expressive, which is exactly right, I think, trying to build more expressive systems. It's all there. So definitely in this class, if you wanted to take it and try to build a system like this, that would be amazing. There are many other directions to go in as well. So I'll just show some other cool examples. This is something that I saw the other day. This is someone combining a rainbow export, so an export of a max patch, with something they built themselves in Unreal Engine. So we can take a look at this. Wait, there's a way to make this. There's a way to make this full screen. What if I? Okay, whatever. I'll do this. So just to explain a little bit what's going on here, all the pieces of this that you're seeing, the graphical part, is all done in Unreal Engine. The sound design part, all done in Max, this like automatic break core generator thing. And we'll see how to make a system kind of like this in another couple classes. But It's taking a, you have this cool way of interacting where you're flying around and kind of painting this world, and there's a complementary quality between that way of seeing what's going on and what you're hearing, where the two pieces coming together, it's kind of greater than the sum of its parts. Okay, so I wanted to show you that one, and then I wanted to show you, so this is a performance by someone called Leafcutter John. I've been following for many years, who just does such cool sound design work using systems that he builds in Macs and with other kind of electronic and computer music components. In this case, it's just a contact microphone, I think, on this drum, but then the processing that's coming afterwards is just really, really interesting and makes some really beautiful sounds. Yeah, I can only speculate about the sensors involved there. I'm pretty sure there's a contact microphone, but then maybe a pressure sensor as well. But in any case, there's some really interesting processing happening in the background, converting some of what's happening to a synthesized sound process, but I don't know if that's coming from, I mean, there's so many ways to make those sounds, but I just think it sounds really beautiful together, the amplified stone with these kind of harsh synthesized tones as well. And then the last thing I wanted to show that might be inspirational the last thing that might be inspirational, especially if you wanted to design a musical system that you could use in your browser. This has been out for a long time, but this tool called Patatap, toy, basically you can push any one of the letters on your keyboard in a different sound. So I'm not the world's most talented finger drummer, but you get the idea. And obviously a lot of sound design goes into this, but really it's just playing back samples and doing a little bit of processing or P5 style drawing on top of that. But really fun and effective, I think, given kind of an economy of parts. So the very last thing that I wanted to show that I think would be another really cool thing that is definitely possible to build in this class, and I would love if somebody wanted to take this on, would be to design a tool. And I'm really inspired by the work by this guy, Kentaro. Actually, it's Kentaro and his brother who run Kentaro tools, they make Max for Live devices, VSTs, and audio units, so tools that you use in sound production with, I think, very beautiful interfaces and very crafted devices around synthesis, effects, sequencing, and I'll give you a little taste of one that was developed, or either is running in Max or was developed in Max and Rainbow. Yeah, just a super beautiful and really expressive tool. So that covers, I think, kind of some of the things that we can talk about making and that you should, I think, feel inspired and encouraged to try to make either during the course or as your final project. That includes, again, like VST tools, web tools, embedded technologies, and even if you wanted to just make a composition or something like this using Max and Rainbow and any other pieces of technology that we'll pick up throughout this course, that's definitely the kind of thing that I think you should try to do. So with all those things out of the way, I think now there's nothing stopping us from getting in and talking about Max itself, building up some fundamentals, and then getting into some sound design techniques. So let's get started. You should have Max installed at this point. I think for the very first class, people may just have the demo, and that's totally okay. There's a month-long demo, I believe, and that's good. And we'll get licenses sorted in the meantime. But if you've never used Max before, welcome. This is what it looks like. When you first open it, I think you'll just see the console. We'll talk about what that does in a second, but in any case, you can make a new patcher, and if your installation is all messed up like mine, you'll see a bunch of messages, but probably you'll just see a lovely new blank patch like this. So what is this patch? Everything in Max is basically everything boils down to objects and messages. You connect objects together to create some kind of behavior, and objects send messages to each other to decide what to do. So for example, I could just make an object like Metro, and this Metro object sends out a bunch of messages, and those messages are bangs. If I make a button and connect Metro to button, and then I make a toggle and connect that to Metro, and then turn this thing on, the Metro will start blinking. That's way too fast. Let's make it just like a full second. And you can see that metronome blinking away, or rather sending a message and making this button blink away once every second. So let's talk a little bit more about some of what's happening here. One thing you'll notice is that I'm locking and unlocking the patch. So that if the patch is unlocked, that's when you can move objects around and change them and create new objects, create connections, all that kind of stuff. And then when the patch is locked, that's when you can interact with UI objects by clicking on them. You can lock and unlock the patch by going to, I don't know where it is in the menus here, View, No. Object? No. Arrange? Options? Debug? Windows Extras? How do you lock the patch from up here? Oh my God. Oh, it's edit. It's called edit. Okay, so it's edit or Command E to switch between lock and unlock version of the patcher. You can also click the lock icon down here to lock or unlock. I'm making new objects by just pressing N to bring up the new object. You can also drag in a new object from here if you like, and then just start typing into it. And you can see that some objects, here I'll just zoom in a bit. You can see that some objects are sort of just look like text, like this. Most objects are like this, the default object look. Some objects are UI objects like toggle and button here. You can drag some of these objects in from the toolbar up here, or you can just make a new object box and type their name. UI objects like button and toggle, these will, you can type them into a normal object box like this, and then they'll, when you press enter, they'll look like their UI, their special UI shape. Another useful object is comment. You can just type comment, or else you can press C. So toggle is T, button is B, new objects are N, and comment is C. And you can type anything you want into a comment and just chuck that somewhere in your patch. So this is a toggle, press T. This is a button. Oh, you know what? I'll bring this down here. And this is obviously a metronome. Okay, so when you're in a patch like this, what was I going to say? So let's say, for example, you didn't know what this metro object did. You opened up someone else's patch, you saw something that said metro, you were like, I don't know what that is, what does that do? You can always right-click on the object and go to Open Metro Help, or Option-click on the object, and you'll come to a help file that will explain to you exactly, hopefully explain to you exactly what the object does. And one of the cool things about all these help patchers is that these are just regular patchers. You can lock and unlock them. You can come in here and copy whatever you find in here and paste it back into your patch. So you could say, take all this, copy, close this, and then paste it. And now, you've got your own metro, or rather you can, whatever was in the help patch, now it's in your patch. You can even save the changes to whatever you do in the help patch. If you modify the help patches, hopefully you don't break the help patch that way. So you may have noticed that this metro, I typed the object name metro, and you can just type metro like this, but you can also put in this argument afterwards. And this argument is, or rather this number afterwards is an argument that defines the initial state of the object. So this metro is initialized to 1000, meaning that by default it's sending out bang messages once every second, or once every 1000 milliseconds. But you can also change that. So there's a few ways to change that. You can either use messages, or it would be using messages, but many different objects can control that metro. You can make a number box by pressing I. So this is an integer box. Press I. A floating point box. So this is floating point box. Press F. Both of these, so the only difference between these two is that integer boxes always represent whole numbers, and the floating point box always represents, it can represent whole numbers, but it can also represent fractional numbers. So if I connect either of these to the right inlet here, now I can control what this metro is doing by changing these numbers around. So if I hit this toggle, right now it's blinking at 1 second, but if I come to the integer box and I type 250, now it's blinking every quarter of a second. I could type 3000, and now it's only going to blink once every 3 seconds. You may notice that this still says 1000 down here in this metro, and that's because even though we've changed the value that this metro is blinking at, it still is, the initial value was still 1000. And if I close this patch and I reopen it, this metro will be blinking at 1000. So all these changes come afterwards, and they do override the kind of internal state of this metronome object, but they don't change what you see here in the box. And granted, sometimes this can be a little bit confusing. So if, for example, I deleted this box, this metro says 1000, but it's actually blinking at 3000 because the message got sent and it changed the internal state. And that's because what's in this, and you can see now that like I undid that change and this box says 0, but it's still blinking once every 3 seconds. And that's because what's in this box and what's actually happening in this metro aren't connected. It's just that when I change what's in this box, it makes a message get sent along this patch cord to the object. So one thing that's really helpful, speaking of messages, is if you come to, let's see, where is it? I think it's in debug. Yeah, if you come into debug and turn on event probe and signal probe, these are both extremely useful. Event probe and signal probe make it possible to observe what's happening along a patch cord when you hover over it. So for example, if I take this number box, or maybe let's go to this floating point box, and I type like 600, and then I hover over this patch cord, I can see, it's hard to see, it's a little small, but it says 600 because the last message to be sent along that patch cord was 600. And if I hover over what's coming out of this patch cord, I see a 1. Because the toggle object sends a 1 when you turn it on and a 0 when you turn it off. And if I hover over this patch cord coming out of Metro, I can see that it says bang. And that's because the kind of message that Metro sends out are bangs. So the fundamental kind of messages in Max, there are a few types. So there are I'm talking about the messages that objects can send to each other. There are bangs, and bang is kind of the fundamental empty message somehow, that most objects, when they get a bang message, they just do whatever their behavior is supposed to be. And different objects can interpret bangs in different ways. We'll look at an example in a second. But there's also floats, which are numbers with a fractional part, ints, numbers without a fractional part, symbols, and then lists. And they're actually, as of Max 8.6, which is the version that we'll be using in this class, and the latest available version, there's also arrays, dictionaries, and strings. Talk about that later. For now, this is plenty. There's also matrices and a bunch of others, but for now, this is plenty. So I said that there were, with integer boxes and floating point boxes, you can change the behavior of this Metro object. You can also use message boxes. So I said that you press N to make a new object box, and you can press M to make a message box. So this is a message box. Press M. Message boxes look a lot like object boxes. So this is an object box, and this is a message box. Now, object boxes and message boxes, they can look similar, but they are different. Object boxes actually have some kind of behavior, whereas message boxes, they are used to display and to send messages. So this message box, if I went into this and I typed, say, 250, and I went to another message box, okay, so this is a really useful thing too. If you hold down Option and drag from an object, this is how you can make clones of that object. And I'm using that here, so I can do 500 and maybe like, 100. I can connect these two to this Metro. And in this way, these boxes, I click on this box, then I can drag up and down, or I can type into it to change the value. But I could also click on these message boxes to send an explicit value, a particular number into this inlet. And finally, another useful object to know when it comes to controlling objects like this is the slider. So I can also make a slider, press S, or a dial. How do you make a dial? Oh, I guess there is no keyboard shortcut for a dial. That's kind of crazy. Well, you can also make a dial. This is a dial. And dial is like, so slider, you scroll up and down, obviously, to change its value. Dial, you scroll up and down to change its value. These objects are very similar. And you can also connect the slider, and you can adjust the size so it's horizontal. I prefer horizontal sliders. I'm just that kind of guy. You can connect a slider as well and change the value this way. You can take the value, what's coming out of a slider, and connect it to an integer box like this. And this is actually a very common way to use a slider with a number box, is in this way, because this lets you see the value coming out of the slider. Now, you might notice that this slider is going between 0 and 127. So as I scroll back and forth, the slider values are always going between 0 and 127. This is the default range for a slider, and we can change this by opening up the inspector and overriding some of the default values that are on this slider. So I could select the slider and then open up the inspector, change its behavior. The inspector is in the right toolbar here. It's this little I, but you can also push Command I to open the inspector sidebar, or go to Object, Inspector to change that value. And if I go Command I, now I can come in here and change lots of different things about the slider. So these values here are all for this slider because I have the slider selected. But if I select something else, say this toggle, I can adjust the properties of this toggle or this metro or this comment box or whatever. But I'll work with this slider and I can change the on color, maybe, why not? I can give it a different color. But also down here you can see, and you know what, your slider may look like this when you first open it. These tabs at the top here, they let you go between different selections of properties that this slider object has, but I'm clicking on all. Also under basic though, maybe basic is fine here. Some of the important ones here are float output, mousing mode, range, multiplier. Right now the range is 128 and the slider is going between 0 and 127. But you can also say tick on float output and change the range to 1, and now it's going between 0 and 1. And you may notice, this is kind of important, you may notice that now that I changed the range of the slider to be from 0 to 1, what you see in this integer box is always a 0 or a 1. That's because the integer box can only work with and display whole numbers, integers. So as long as that number is, so even though what's coming in has a fractional part, so if I, hold on one second, rearranging. If I go into this integer box and I look at what's coming out of this patch cord and click somewhere in the middle, say, you can see that the number here is 0.47. So somewhere in the middle of the slider, a 0.6 is coming out. But the integer box just shows 0. And if I hover over this patch cord, you can see that this too just says 0. That's because the integer box only works with whole numbers. And if it gets a number that is partial in some sense, it will round that number down. So just clip that number down to a 0, for example. If you don't want that behavior, then what you need to do is use a floating point box instead. But this is definitely something that, when you get started with Macs, you could be like, what the heck? How come my number is my number is not working the way I expected? And in fact, this is something that can happen all the time. I'll show you another example of this. It's just something to be aware of. If you take this slider, so first of all, if I take the slider and connect it now to this floating point box and not the integer box, you'll see that those values do what you expect. I actually can specify numbers all the way from 0 up to 1 with these decimal values included. But if you tried to do something like offset this value, so say I wanted, instead of going from 0 to 1, I wanted to go from 10 to 11. Well, I could just throw in a plus 10 object here and snap that in. This is a useful thing as well. If you hold down Shift when you're putting an object into a patch cord like this, you can make that object all automatically connect in the middle. So its input to the output of the previous object and its output to the input of the next object. And by holding Shift, you can pull the object out of the connection like that. Also very handy. Anyway, you could also delete this patch cord. And by the way, to select a patch cord, you can either click on it or you can hold down Option, and that lets you select patch cords, and then you can delete them. So you could also put a 10 in here, and now if I start dragging the slider around, suddenly we're back to where we were before, and this thing is only showing values between 10 and 11. That's because this object, the plus object, is running in integer mode and will only only work with whole number values, just like this integer box. And all you need to do to change this is come to this 10 and chuck a decimal point after that. And now this box does what you would expect. It's in floating point mode, and it's working with floating point numbers. Very common kind of gotcha, I guess, when you start to work with Macs. I'll just say of Macs, it is a, like I said, an older piece of software. So some of these things, this constant distinction between integers and floating point numbers, this thing where what an object shows inside of it, you don't get a real-time update with the internal state of the object necessarily. The software Macs has a long legacy and used to run on machines that were very limited in terms of their capabilities. And so things like, okay, this number, do I really need floating point precision? Do I need all those decimal places? Or can I get away with using less computer memory by using a small number? Things like, well, the computer is pretty limited in terms of its CPU, so I better save some CPU by not displaying the actual updated value, but just the initial value. That was a concern a few years ago. So there is a bit of a legacy sometimes built into Macs. And, just if you're wondering why something is the way it is, oftentimes it's just because of that legacy. Let me think. There was something else I wanted to say. Floating point, integers, toggle, metro, start, stop. Maybe that's it. There was something that I was going to say. Opening Mac, sending messages. Oh, yes. Okay, one thing that I should mention for sure is that there is another very useful object called print. And with print, you can see whatever an object is doing. So if I go print, and then maybe I'll make an integer box like this to connect it to print. I type 50 in here and press enter. You see a little green dot has appeared here by the Mac's console. And you can see that my message, print 50, has appeared here in the console. You can always open the console by pushing Command M or going to Window, Sidebar Mac's console, or show the Window Mac's console, they're equivalent. This is where messages that come from objects or from the application will appear. If I clear this and hit print again, let's maybe send it 100. If something goes wrong and you don't understand why your patch isn't making sound, or if you see, especially if you see a red bubble over this icon here in the sidebar, probably what's going on is there's some kind of error, and you'll see a message here in the console that will let you know what's going on. You can always double click on this and it will highlight which object was responsible for sending that message, and it can help you to figure out what's going on in your patch. If you give an argument to print, so you can do print Jerry and then change this, then instead of saying print, it will say Jerry, so you know, you can give it whatever name you want, and it just lets you, puts a label on that print object so you can see what is being printed. Okay, so here's very basic crash course, first steps in Max. Covered locking, unlocking, making objects, sending messages, patch cords, connections. This is great. Okay, so there's our good starting point. I think now we're ready to make some sound. So I'm just going to save this. Hang on. I will put this in Sound Studio 2024. Make a new folder called In Class, and we'll do In Class 1. Of course, we're not really in class. We're in, I don't know, internet class or something. Okay, I think now we're ready, finally, to start making some sound. So I'm going to close this, and in order to make sound, we're going to be using a package that I've made for this course that just simplifies some of the initial noise-making stuff. To get this package, I will put a link in the description, and also there'll be a public link for non-NYU people and an NYU link for NYU people. That link is, oh man, what is the link? Oh, I don't want to open my AWS. Hang on a second. If I do bucket of chum GM. Yeah. Okay. Whew, found it. Here's the link. I will make this. I'll put the link in the YouTube description or something. But with this link, you can download this package. And if I go into my downloads and unzip this package, you can see it's called GM Lite. It's just a collection of a couple of small objects, piano and a drum kit that we can use to make some sounds. And all I'm going to do is install this. And to install it, what you need to do is go into, on Mac, I'll show you how to do it, and then on Windows, either get in touch, we'll figure it out. I can't remember exactly how to do it, but basically you go into Documents and then into Max 8 and into Packages, and then all you do is take this GM Lite and drag it and drop it in here. As you can see, I've already done that, but all you do is take this folder, drag it and drop it in here, and then you can make sure everything is working by coming into Max, and if you make a new patcher and just type GM Piano, you should see an object get created that actually looks like this. If you see something that looks like if you see something that looks like this kind of salmon colored object, then Max didn't make the object correctly. You didn't install the package correctly. Either get in touch with me, whatever, we'll work it out. But this is just a handy little object that will take care of some basic stuff for us in terms of making sound. If you're curious and you want to see how it works, you can always lock your patch, double click on this, and then as you can see, it's using the brand new and very fancy SFizz object, available only in Max 8.6. So that's kind of cool. Anyway, we'll cover that later. The important thing is that we can use this to make some sound. We now have all the pieces together from the... and you know what? Now that I see that in the Max console, it says GM piano, no such object. That's from the other object that I tried to make before. And if that object were still around, I could have double clicked on this and it would show me which object was the one that didn't exist. So let's make some sound, shall we? What this object does, there's two inlets here, one for pitches and one's for velocity. So it's time for us to talk a little bit about MIDI. So when you go to a MIDI keyboard, and this is a K slider, can you make a K slider by pushing K? K slider, no. But you can say, this is a K slider, K slider. Whenever you hit a MIDI key on your keyboard, there's a lot of different things that can happen, but at a minimum, it will probably generate two values. a pitch and a velocity. The pitch is, of course, just which note you're hitting, and the velocity corresponds somehow to how hard you've pressed that note. So we can just type pitch and velocity. MIDI, MIDI stands for, I believe it stands for Musical Instrument Digital Interface. Sam, you're teaching this class. You've been working in computer music for a long time. You don't know what MIDI stands for? Yeah, I don't know what MIDI stands for, okay? Musical Instrument Digital Interface. Musical instrument, or maybe I do know what it stands for, and I knew the whole time, and I was just testing you. So anyway, yeah, MIDI is actually like very low-level serial protocol for communicating between musical instruments that now actually is used for lots of things that are not musical instruments. But it's crazy. I mean, I think it's kind of crazy that this protocol, there's devices you can buy today, plug them into devices from the 60s, and they just kind of work because they use the same interface. Anyway, I got sidetracked a little bit, but the point is that when it comes to MIDI notes will have a pitch and they'll have a velocity. And there are note on events to start a note and note off events to stop a note. And if I connect this pitch and this velocity to the GM piano, and then there's one more object we'll need here called EZDAC tilde. This is the first object we've made that uses the MSP part of Max, the part of it that actually makes sound. And all of the objects that make sound in Max have this little squiggle following them, the tilde. And this is the one that we use. So there's another companion object to this called DAC tilde. The only difference between EZDAC and DAC, other than the spelling, is that EZDAC lets you turn audio on and off by clicking on it. So by default in a Max patch, no audio is actually processing. But if you click this guy, well, okay, so in my computer, it's all jacked up and you have to actually go into, I mean, maybe this will happen to you as well. This should turn audio processing on or off. In my case, I've got to go into options, audio status, switch to headphones, and then turn this on. And now audio will process. So there's lots of ways to turn audio on. You can click an EZDAC. You can click this little thing in the bottom right. You can go to options, audio status, and turn it on that way. But this, yeah, lets you turn on, that turns on audio processing. And then if I connect this to this, like so, this is for the left channel and this is for the right channel. And now all we need to do is press one of these keys to make some sound. Now, before we make some sound, I'll just say it's very possible and very easy in Max to accidentally make very loud sounds and hurt your ears. So just be careful. This is a volume slider over here. You can use this to adjust the volume before you hear anything. You could also throw in an object like gain tilde. This is a gain tilde. That just is a volume slider. And there's the version of gain I prefer to use called live.gain. This is called live.gain tilde. And it's a volume slider that you can use to control volume. And maybe I'll just chuck that in here, in fact. So we have it, some way to control volume. It also provides a nice visualizer. It is a little bit annoying to get it all hooked up, but there it is. And now if I hit, I'll just bring this down and start hitting a button. And if I bring this up, incredible, we've made some sound. And you may notice that these sounds are just continuing forever, and that's because we've sent only note ons and no note offs. And there's actually no way to clear out all those note on and offs. I haven't made this object in the right way to handle that. So I'm just gonna delete it and then make another one, GM piano, and connect it back up. So there's a few ways to generate note offs. One way is with the flush object. So flush just listens to velocity, to pitch velocity pairs, And when it's time, when you want to, you can just hit the flush object to make it flush out all the note offs for any held note ons. So what the heck? So if I connect flush in here, and actually I don't remember how flush works, so I'm just going to pop open the help file by holding Option and clicking on it. Okay, so you see flush gets a note on messages come in here, and you can hit the bang, or rather when it gets a bang, it will send out any note offs for any note on messages that it's received. So I'm going to make a button here and connect it like so, and then play some notes. And then when I want to get rid of those, just hit this bang, and the note offs come out. Okay, so that's the pitch and velocity being flushed like that. There's another object that's really useful in this case, and that object is called make note. Make note basically handles making note off messages for you automatically. So if I take make note and I give it an argument, and that argument is like, I don't know, 200 or so. Oh, well, the argument's, so it's similar to the way that Metro, so we have Metro, 250. Here, the initial argument for the speed. But we can also come in here and go make note. And make note takes 2 arguments. Actually, it can take 3, but there's at least 2 arguments here for the default velocity, the default duration. And you'll see there's an input here. So in the same way that Metro has this other input that lets you adjust the time interval, Make note has these 2 inputs that let you adjust the velocity and the duration. So if instead of flush, this is one way to do it. I'm going to, I'll leave all this here and I'll just copy it, I guess. I'll take this whole thing and copy it. And then instead of flush, actually what you can do that's pretty cool, check this out. So I'm going to copy this make note and then right click on this flush and do paste replace. Look at that. You got to admit, that's pretty snazzy. I'm not sure you were always able to do that, or I don't know when they added that feature. But this make note, because of this 250, has a fixed duration for these notes. So if I hit a note, it's always 250 milliseconds long. Now, it doesn't have to be 250 milliseconds long, that's just the default. I could make an integer box here and connect it up like this, and now I can set the duration to be whatever I want. And I could do like 1,000 for 1 second long notes. Or I could go really short and like for 1 millisecond long notes. To make notes that get turned off immediately the second they're created. So make note, yeah, the flush is one style and make note is another style. So once we've got kind of this system going on, we're ready to start doing some interesting stuff. So combining this with something we've already used, we can, actually, you know what, I'm just going to make this flush and this make note. I'm going to give them a different color so they stand out a little bit more in this patch. Maybe like a nice blue, maybe like this. Yes, that looks good. Okay. So with this set up, I think we're ready to start doing something kind of cute. What if instead of actually clicking on a note to play a note, what if we said, you know what, I just want to hear notes, okay? Let's just make something happen. Well, in that case, let's combine what we already have, this Metro object, with this system here. So I'll do Metro into, and now let's say I want to just like play middle C a lot. So I'll make a slider, I'll make a slider Do 250. I'm actually realizing that I might crash max when I do this, but let's see what happens. So I'm going to connect the Metro to this keyboard, and I'm actually going to pick a, so this is a message box, and one thing that's nice about message boxes is that they can hold a list. So this K slider, you'll see it has two inputs, one for the velocity and one for the display. Similar to a number box or a slider or a dial, you can click on it in order to have it generate pair or generate whatever value it's going to generate. But like those objects, it can also accept a message to set its value. So you can use that as a display as well. So if I do something like, say, 60, I don't know, 80, this is it should be middle C at velocity 80. Oh, I should mention, by the way, in case I haven't already, that each note gets its own pitch. Tiny bit of music theory here. Each note gets its own pitch, and there are 12 notes per octave. So if C, I believe C is 60, middle C is 60. I feel like there's some keyboards where it's 72 or 48, but this should, if I click this, you'll see it's just playing a note at 60, MIDI note, on the C at MIDI note 60. The C one octave up, that would be 72. And one octave down would be 48. But we could do something like this to hear just that C. And then if I turn this Metro on, we'll start to hear a lot of those notes. And you can actually hear there's like something kind of fun going on there, especially when the values start to creep down towards the lower end of the, when you start to play it really fast, another pitch starts to come in. And that's because the notes are actually playing so fast that the rate of the notes being played, instead of sounding like a rhythm, it just sounds like a continuous pitch. We'll talk about more about this when we talk about synthesis a little bit later. But like this, we can start to make different kind of notes, or rather we can play those notes automatically. And now, actually, I'm gonna arrange things so we have a little bit more space here. I'm gonna get rid of this, move this down here, move this here, move this here, get this guy down here. I might get rid of this because we know what it is. I'm gonna get rid of this. I'm gonna make this a little smaller. Just hold on, I'm arranging things. K slider, we know. Okay, so what if instead of playing middle C all the time, I want to hear some different notes? Let's try some random notes. So how about we just do random 127. So the random object, this object takes on, rather you send it a bang and it puts out random values. So if I bang on this random, you'll see that what comes out of it is just some kind of, well, not surprisingly, a random number. So I'm going to start hitting this bang, 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 bang. And these are all different numbers between 0 and 127. You can set the range using this inlet here. And if I put this thing after this Metro, we can start to hear, instead of middle C, we'll hear a bunch of different random notes. So let's try this. I know it's just random notes, but like I feel like it doesn't take much to make it sound a little bit musical, to me anyway. You may notice that some of these notes, it sounds like there are some notes being missed. I think basically that's because this instrument, the piano, the GM piano instrument doesn't have an infinite. Sorry, the GM piano instrument doesn't have an infinite range. So if you send it a value like 16, for example, there's no piano note program for that. If you send it a note like, I don't know, 110, for example, there's no piano note program for that either. I don't remember what the range actually is, or I don't know what it actually is, but we can look. So if I double click on this and double click on this, this is the SFZ file. I'll get out of here. This is the SFZ file that actually determines the, when you send it a note value, what what you hear. So it looks like the low key is 20. I'm just eyeballing it. I don't actually know, but it looks like the low key might be 21, and the high key might be group 2, low level, high key 108. Maybe it looks like. So yeah, from like 10. Yeah, like so 21 to 108 maybe. So we can just test that really quickly. If I send this at 20, let's try like 20, 21, 108, and like 109. And let's just see if this actually, so nothing. So nothing for 20, 21 is the low note, high note 108, nothing for 109. So between 27 and 108, that's where we're actually hearing notes. And we can use this. So if we're like, this is only between, or only accepts notes between 21 and 108. There's a few different ways that we can kind of like, so right now, I actually think it kind of sounds cool. I think it sounds kind of cool that that particular note doesn't, what was I going to say? I think it sounds kind of cool with some gaps in it occasionally. But maybe like we want to be more in control of that. And we don't want to, like, if we swapped in a different, like maybe we want to make that controllable, because if we swapped in a different instrument, for example, that instrument might not have gaps in that range. And then if what we really wanted was a gap, we wouldn't hear it as soon as we swapped out the instrument. We'll look at in a second about how to add those gaps in on our own, but we could also control the range coming out of this random object. So if, for example, right now this random is going from 0 to 127, we could instead make it go between 21 and 108. There's a couple ways to do that. I would say the easiest way is probably to subtract 108 from 21. So I don't need a calculator for that, hopefully. So that should be what, 87? So instead of going up to 127, we'll do random 87, and then we'll just add 21 to whatever's coming out of that. And now hopefully this should be between between 21 and 108. And we shouldn't hear any gaps when I turn this Metro back on. So already, so yeah, there you go. No more gaps in this little noisemaker thing. This is, already we're making some sound, and I think that even with a very small number of parts, there's something vaguely interesting, kind of musically going on here. And if we wanted to, we could record this output. How do we record this output? Easiest way is to come up to extras and go down to quick record. If I hit quick record, and then this little window here lets us record any of the audio output coming out of Max. And as you can see, it actually goes up to 8 channels. So if you're, or maybe more, I don't know. It goes up to 8 channels. And if you want to, make some kind of sound that has, or record some kind of sound that has a lot, for diffusion maybe, for like 8 or more speakers, you can do that, and that's kind of cool. You can actually record more channels than this with different recording mechanisms in Max, but if you're using quick record, this is you're limited, I guess, to 8 channels. So I'm going to choose a directory. You can either pick a specific file to record to, or hit choose a directory. I'm going to hit choose a directory. That way I can just kind of like keep making recordings as I just whenever I want. And I'll have those. So I'm going to, yeah, let's go into oh my gosh, where is it? Sound Studio, and then we'll do quick records, class 1. Okay, so now if I just hit record and then come back into this patch and make some sound. Now that's been recorded. And if I hit this record button again, so it said recording, and now if I hit record, it's done. And if I go to that file on my computer, quick records, and hit this. Thank God. I was worried for a second I hadn't recorded. Actually, let me just make sure this is all actually being recorded in OBS. So if I play this, oh, thank God. For a second, my heart stopped. I was worried that OBS had recorded none of the sound. I was going to have to do this all over again, but right. So that's quick record, and using that, we can start to record some output from this thing. So this is, I think, just like the beginning. And what I want to do for the rest of this class is just look at like ways we can build on this, make this more interesting. Because I think even with this kind of economy of pieces, just a piano and this thing that's making, or this metronome that's making these pulses, and just by shaping the kind of numbers that come out of it, there's a surprising amount of variety and kind of interesting things that you can do. So I'll set quick record up here. I'm going to save this to in class, and we'll call this in class 2. And I'm going to save as in class 3. And I'm going to, what am I going to do? Let's look at some ways that you can shape the output of this thing a little bit. So one thing that that I think makes these processes sound, well, first of all, one thing that might be nice to do would be able to start to add some kind of control to this thing. So we've got this slider here. There are other ways to interact with this patch that we can start to lean on. For example, there's the key object. So if I go to key, key sends out a message whenever you press a particular key. So escape, or rather spacebar is 32, escape is 27, different, oh, I haven't turned off edit mode, but different values here. So 1, 2, 3, 1 through 9 is 49 through 57. These are just the ASCII values of that particular key. But if we use key in conjunction with a select object, we can add some keyboard control to our patch. So for example, I can do cell 32. I should mention this cell is short for select. And this, maybe I'll make these objects, give them some special color as well, maybe like a red. These objects, the select object rather, it waits for a particular number and it sends out a message when it gets that number. It sends a bang specifically when it gets that number. So this select is waiting for a 32. Actually, you know what I'm going to do? I'm going to put this in here. This select is waiting for a 32. And if I push all the different keys on my keyboard, it's just doing whatever. But then when I finally push spacebar, which is 32, it recognizes it and sends out a bang. And I can use this, if I want to automatically turn this metronome on or off by pressing spacebar. So. So we're starting to add some kind of like control to this thing. There's another useful object here called mouse control, maybe just called mouse. One other object you can make use of called mouse state. And mouse state will tell you what the current position of the mouse is. And if we take if we send the mouse state the poll message, so far I think this is the first time we've seen an object that is responding to a message that is not a number. And first of all, I should just say this is a message box containing the message poll. This is an object called mouse state, and yes, they look very similar, but one of these contains a message that will be sent to an object, and the other is an object itself. When mouse state gets the poll message, So most objects, they'll respond to a number or a bang by doing some kind of default behavior. Mouse state responds to the poll message by starting to poll the mouse state and reporting. I'm just noticing that there's a typo in here. That's pretty funny. If you send it the poll message and then watch the second and third outlet, these will tell you the horizontal and vertical position of the mouse. So right now they're doing nothing, but then if I hit poll, you can see that it's telling me where the mouse is on the screen. And you can use this to build a kind of automatic controller, which is a little bit, which can be kind of fun. So for example, the horizontal position goes from 0 all the way up to 1728. Not the screen dimensions I was expecting, but I can use another, so I could just like take this mouse state and connect that straight up to Metro like this. And now if I turn it on, near the left side of the screen is fast and near the right side of the screen is slow. That range, 0 to 1728, might be way too big, or you might not like that range for whatever reason. And now we'll come to talking about one of the most useful objects in Max, and that's the scale object. So scale, super important object. It lets you take numbers in one range and convert them to numbers in another range. It probably will drive people crazy if these are different colors of green, right? So I'll just make them the same color green. The scale object, takes a range in and produces a range out. So generally you'll see it with 4 arguments. Those arguments are the low and high input and the low and high output. So mouse state here, for me, is going between 0 and 1728. So my input range could be 0, 1728. And then my output range is whatever range I want, depending on the system that I'm connecting this thing to. So maybe I want my input range to be like, I don't know, 5 milliseconds all the way up to 700 milliseconds. And if I connect this in the middle here, you can see the scale values coming out of it. So the horizontal position of the mouse is between 0 and 1728. But after the scale gets involved, the scale value is between 5 and 700. If I turn the Metro back on now, I can control this thing just the way I want it. So right now, all these notes that are being generated, they're just like completely random. There's a musical quality to it maybe, but it's not like the most musical thing in the world. So what are some things we can do? Well, one thing that we could do is maybe like we want to add a little bit of looping quality to this sound. So this random sound, once it's, if you take a sound and you basically any sound you take, if you take that sound and you start to loop it, very quickly you end up with something that has a musical quality to it. So by adding a little bit of repetition, well, I'll show you what I mean. So what I'm going to do is I'm going to change a little bit about how this note is processed. I'm just going to move all this stuff down. And then what I'm going to do is I'm going to add in a counter. And this counter object counts bang messages. And it's going to send out a different message. As it gets more and more bangs, it's going to just count up from 0 to 3. And then using a select object, similar to what I did over here, I'm just going to treat 0, a downbeat, differently from a 3 or a 2 or a 1. And in this way, I can start to program a little pattern. So I could do something like counter 3 and then select 0. And maybe for a 0, I'm always going to send out a MIDI note, I don't know, like a 58, for example, a B flat. And then for anything else, I'm just going to pick a random note. So every fourth note, I'm repeating something. And I think you can sort of hear that even though there's a lot of random notes in there, there still is kind of a tonal center, a sense of a key almost. And you can emphasize this even more if you did like select 0 and then 2 maybe. So now I'm picking up the first note and the, I don't know, the third beat maybe. And I could go like up an octave. So from 58 to 70 maybe. And now we might have an even stronger sense of tonality. Just by adding in, yeah, a little bit of selection there. We can play with this some more too. We could, so rather than always having this thing be totally random, we could pick a random, so the random number is not obviously like really truly random. Hold on one second. It's just pseudo-random. So it's not actually picking a number that's drawn from some kind of real noisy process. It's deterministic. There's an initial condition called a seed, and every time you bang on the random number, it's just generating, it's going to the next number in the sequence. And the sequence is very, very long, and predicting the output of the sequence is very, very hard. So it's basically random enough for most purposes, but it is deterministic, and because of that, we can reseed it if we want to generate a unique pattern. So we can actually use the random object kind of like as a database of patterns somehow. I'll show you what I mean. So instead of making a truly random, so rather what I'm going to do is make another counter here. So that counter is counting up to 3. I'll make another counter that counts up to 15. And this counter, all I'm going to do is cell 0. And so this is just going to send a bang once every 16 beats. And what I'm going to do is on the 16th beat, I'm going to send this random number the message, seed, and then any number here, it doesn't matter, but changing the number will let us change the pattern that we're going to be generating. So let's just do seed, we'll do the course number 6113. And we'll see what this does. So you can hear it's actually repeating that pattern once every, rather the pattern's repeating every 16 notes. So you can change this, like you could make instead of a 15 note pattern, you could make a 32 note pattern. Or you could pick a different seed. So this is just a, this choice of seed could be anything. Just go back down to 15 here and then pick a different seed, maybe like 1988, and then we have a different pattern. Right now, I'm using this seed in order to generate random notes, or try to pick different pitches, but you could use this random seed for anything, random velocities, random durations, even whether or not the note goes through. And in this way, we can add back in that kind of like occasional dropped note thing that we were doing before. So I could, instead of picking a random pitch, or maybe in addition to picking a random pitch like this, actually I'm going to say this is in class 3, and then make a new one called in class 4, and we don't need this stuff anymore. I'm just going to delete this and bring this over, bring this over here. So instead of generating a random pattern of notes, we could generate a random pattern of on and offs. So that could look something like this. I could, let me think. So let me get rid of this. And, okay, so for now, I'm just going to actually even get rid of this. And I'll just make a random 1, 2, 1, 2. And this will just make random numbers between 0 and 1. So if I hit this random, you'll see the output is always either 0 or 1. And I can use this as a gate just to filter out different notes. So in this way, I can actually make like kind of a pattern. I'll show you what I mean. So if I do, let's start sending the same pitch over and over again to this thing. It'll make it a little bit easier to hear. Let's do like, I don't know, pitch 63. So there's a 63, and what I'm going to do is every single metro hit, I'm going to send a message to this 63. I just did something here by accident that I think is worth pointing out. If you happen to connect, so you'll see that this message box has 2 inlets, one on the left, one on the right. If you connect something to the right inlet and then start to hit it, or rather start to send it messages, you'll see that whatever was in your message box, it's now been overwritten by the message that got sent into the message box from the right. And that, it overrides whatever's in the message box. And then from that point on, whatever was in there has been lost. So the 2 inputs to message box, they do different things. On the right, this is, if you send a message in there, it will get stored in the message box. And on the left, if you send a message in here, it will send out whatever is in that message box to the current output. So just be careful to use the right one. I mean, I made that same mistake. But anyway, I'm going to set this back to what it was, 63, and be sure to use the left inlet to send that message. And then what I'm going to do is with this random, I'm going to I'm going to randomly either let that note through or not. So I'll do something like gates. Okay, so there's a new object here called gates. And gates can either be, you can actually make gate have it can have any number of outputs, but by default it only has 1. And I'll show you what it does. So the left inlet controls the gate, whether it's open or closed, and the right inlet is whether that number, or whether that message rather, whatever it is, goes through. So normally the gate is closed and nothing gets through, but if I open the gate, then all these messages start to go through. I close it, nothing goes through. So there's actually a UI object called ggate that demonstrates visually what's happening. Although ggate is a little bit different in that it always has 2 outlets, and you can control where that message goes. So if I connect it up like this, you'll see that by default nothing gets through, and if I hit this, now things are starting to go through. So maybe just for fun we'll use, this is called ggate. I don't know why, graphic gate maybe. Just for fun we'll use ggate in this thing, I guess. So I'll chuck this over here, and what I'm going to do is a bang will come through here, and we'll use this random, and maybe it'll be easier to visualize this as a toggle, but we'll use this random to control this gate, and then we'll send this value through only when that toggle is open. It actually doesn't matter whether we send it through when the toggle is up or down, but in any case, this should generate a unique pattern. So now it's like, before, every beat there was a note, and now there will only be a beat on certain notes, but there will be a definitive kind of rhythm. Apparently not. Why not? That's because this select, or this thing isn't getting a bang. I actually want to do it like this. Okay, let's try again. It's not a very interesting pattern. Let's go down to 8 beats, might be easier to hear. Okay, a recognizable pattern for sure. We can make this a bit more interesting if we add some other notes into this whole process. So I'm going to take this mouse state guy and just chuck him up here. I'll move everything down a little bit. So I'm just going to add in some more notes here. I'm going to take all this stuff and just copy paste it a couple of times. So we can take this, hit Command D to duplicate, drag it to where we want it to go, and then hit duplicate a couple more times. And now we could have 3 pitches. So maybe we'll do 67 and like, I don't know, 61. And if I connect all these up, a lot of connections to make here. So I'll connect here, 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 and here. This looks like a mess. I'm going to clean this up, and I'm going to clean it up by making a trigger. And what trigger does is it takes one input and sends it to multiple outputs. And trigger is actually really handy because it also makes the order of operations really explicit. Whatever goes into this trigger object, it will always fan out from right to left. So if I hit this trigger, you can't see it because it's very fast, but I hit this bang here, and first this message goes through, then this message, then this message. And by using these triggers, I think I can make this a little bit cleaner. So I'll put a trigger here, and then connect it to this counter, to this random, and to this note. And then I'll do the same thing here and here. So this will go like this, this, and this. Nope, this. This will go like this, this, and this. Cool. And now I should be able to go like this. And that's looking a lot, looking a lot cleaner already. Okay, let's listen to this. One more thing. I want to change the seed. I don't want them all to be using the same random seed because then they'll all have be playing the same note at the same time. So this one's 88. Why not make this one 89 and make this one 90? Okay, let's listen. But what I didn't do is I didn't actually connect these to the keyboard. So let's do this. This might be more interesting as a drum, not as a piano. So let's try that. Let's try, so it's still true of GM piano that it only accepts notes, but let's do like GM percussion. Nope, GM percussion. It is a little bit more satisfying. Right now, it's also very like stale. It's always the same rhythm every time. So we can adjust that a little bit by coming down here and like right now the rhythm is always 80. We could make the rhythm something, the velocity is always 80. We could add a little bit of variety to that, I think. So let's just do, let's have one more thing over here. That's just random. Let's make it a little bit of randomness. So we'll do like random 30 and then plus 70 to give random numbers between 70 and 100. And we'll plug that down into the velocity here, like this. Actually, you know what might be kind of cute is maybe we want to Maybe it would be better to, yeah, what if, okay, so what if we did counter 7 over here, and whenever it's a 0, so on the downbeat, we pick a louder velocity, basically. So on a downbeat, it's always 110. Otherwise, oh, but let's do it like, we'll do it like this. Make things a bit simpler. So on any other beat, pick a random velocity, but on a downbeat, pick a velocity of 110. Okay, that's fine. Maybe, okay, everywhere where it says counter 7, let's change that to counter 15. So we have a longer rhythm to work with. Let's listen to that. Okay, but now let's, instead of selecting 0, let's select a few different beats. Let's select like 0, 4, 8, and 12. So every 4 beats. Okay, let's do this a bit differently. Instead of selecting 0, 4, 8, and 12, let's throw in a modulo. We'll do mod 4. So mod 4, this is a really cool object that's important to kind of like at least know you have available in your toolkit. So modulo takes a number in one range and wraps it around to be in a smaller range. So for example, if I take a mod 4 here and chuck a integer box after it, when I connect it up, you'll see that I'm counting up and up and up and up and up, but this number is always between 0 and 4. So when I'm at 0, 0 is 0, 1, 1, 2, 2, 3, 3, but 4 goes back to 0. 5, 1, 6, 7, 8. So this is just doing a division by 4 basically and giving you the remainder. And that's kind of cool because we can use it here to program patterns. So right now, this is the same, 0, 4, 8, and 12. But I could change this to 5, and we'll have another kind of syncopated pattern of emphasis. It's subtle, but listen to 4 versus 5. So here's 4. Here's 3. So yeah, you can play with the velocity, and maybe we'll emphasize it a bit more. Instead of random, we'll do plus 50 and change this to 60, and that will really emphasize it. Let's try one more time. Yeah, you can really hear it now. Yeah, now you can really hear it. Okay, I could just go on and on and on and show more and more and more things that you could do here. That's really cool. Maybe I'll show one. I'll show one more thing I think you could do that would be fun. I'll show 2 more things that you could do that would be fun. One thing you can play with, so I'll save this as in class 4, and then we'll make one more in class 5. And then, okay, so one other thing that you can do that I think is kind of fun is you can play with the tempo a little bit. So like rather than always using the same tempo, we can play with both the duration and the interval between the notes. And I said that out loud. I don't actually know what I mean when I say that, but let me just try something and see how it works. So I'm going to delete this, delete these. Let's see if I can do something interesting here. So let's go back to the piano for a second. And now, I think how I want to do this. So maybe what we'll do is randomly we will change this to be, I want a pattern of, I want to make the notes different lengths somehow. Or maybe that's not what I want. Maybe I want to randomly, well, let's try something. So one thing that I'm thinking that could be fun is to just like add a bit of randomness to this thing. So maybe what we'll do is we'll take the number coming out of this guy and we'll multiply it by some value. Maybe, let's multiply it by 1 for now and send that into here. What I'm actually going to do, this is a little extra, but I'm going to, so you'll notice one of these inlets is pink and the other one is blue. That's because one is hot and actually triggers the calculation, and the other is cold and does not trigger the calculation. What that means is that if you have a number box over here, or an operation box like this, and you connect it up like so, if you change this box, so you change the left box, the output is actually calculated. If you change the right box, nothing is calculated until you change the left box, and then the calculation actually goes through. So I'm just making you aware of that because I'm going to connect this slider here to the leftmost or the rightmost box that doesn't actually adjust the value. And then I'm going to connect this mouse state into this slider. And you'll notice that the slider is actually clipping, and that's a little bit annoying. It's because the slider is in the range 0 to 127. So I got to come into the inspector now and adjust the slider so the range goes up to 700, 700. Cool, and now the slider affects the full range. And what I'm going to do is, in addition to generating a random pitch here, I'm also going to make a random delay. How to do this? Maybe I'll just do random 100, and then I'll use a scale object. I'll do scale 0 to 100 to be in the range of 0.5 to 1.5. And this should add like a lot of wiggle to this will add a lot of wiggle to I'm connecting back up to the top here so we can change, every time a new bang comes out of this metro, it's also going to be adjusting its own tempo. So that sounds like this. And right now it's basically totally random with a little bit of control over the actual, we can control the density kind of to either be very dense or not dense. But not, we can't control it any more precisely than that. I could, instead of doing 0.5 to 1.5, we could do random 3, and then just go into a select 0, 1, 2, and either do 0.5, 1, or 1.5. And this will just be like, or maybe 2 is better than 1.5. And this will give a very specific, in this case, we're either playing basically a note, an eighth note, or like a half note, something like that. Wait, but I also have this gate going at the same time, so it's a little bit hard to hear what's going on. Wait, get rid of this for a second. Just do like this. Okay, maybe what I'll do also, I'll make this the same thing that's controlling the speed of the metro here should also be controlling the duration. So I'll take this speed going into the metronome, and I'll also connect that to the duration here going into make notes. So we'll have longer notes. And it's kind of monotonous on one note like that. So let's do random 12 and just add 55 to that. So trigger into random into plus 55 into this. I'll be honest, it doesn't sound quite as good as I hoped it would, but it's definitely a little messed up. The thing that I was going to do that I thought would sound cooler than this, okay, we'll do one more thing, and then I'll give the, I'll do a send off. So the thing that I wanted to try was, instead of this random thing, so hold on, let's save this, and then I'll do in class 6. And I'm gonna get rid of this mechanism. It's not really doing what I wanted, but I do want to adjust, still want to adjust this. So what I'm thinking is this: what if once in a while, randomly, we re-trigger the note? So I'm going to throw in a delay, and the delay will always be equal to 1/2 of whatever this value is. So this, basically a trigger, so a bang comes out of this metronome, and maybe we'll do like counter 3, and then cell 0. So every 4th beat, we're going to have a kind of grace note, another note that like sits. So we'll have 4 notes going 1, 2, 3, 4, 1, 2, 3, 4, and then every 4th beat after the 1, there will be 1 note coming in between. So it'll be 1 and 2, 3, 4, 1 and 2, 3, 4, 1 and 2, 3, 4, something like that. Let's see if I can get this to work. So that into the random, into the, nope, not like that, into it like this, and then. And that's a little intense because the random note that's coming through is always something completely random. It might be better to do it like this. Let's flip the order of these triggers. I know this is getting a little excessive, but basically I just don't want that note to be random. I want it to be a specific note. I want it to be like 1/2 step above whatever random note just got generated. So in addition to sending out this random note, I will also store it. So this also stores the number. This is I think, wait a minute, can I take if I set this to like 60 and then I bang it, does it send out its message? Oh, it does, that's so useful. Okay, so I'll just put this here. Oh wait, I don't even need to do that. It's already going into this thing. So this also stores the number. This is not doing anything anymore. So that means that what I can do is hang on, we're getting there. So now every 4th beat, I'm going to, instead of banging a random thing, I'm going to bang on this number box, and I'm just going to add 1. So all this is doing is now every time I get that note between notes, it's going to generate, or rather that note that's coming between notes is always going to be 1 above whatever the note that came before. So it should be like, it's always going. Maybe we want it to be down, not up. Let's try this. Let's try it. Let's see what happens. That is so far from what I wanted to happen. And I think that's because this is actually triggering this to happen, and that's not what I want. So I think I want to chuck a Oh, maybe, okay, I have a different way to do this. I'm going to make a message box that's just has -1 in it. And I'm going to bang on this, and I'm going to add this to, okay, now it's coming together. Now we've got the sauce. I think this will do what I desire. Let's listen to it. Okay, there you go. So there's a few different things that you can do there to kind of like, yeah, experiment with taking these streams of random numbers, shaping them, constraining their scales, playing them in parallel, adjusting the rhythms, and remember that you can use quick record to record whatever you've made and yeah, save it for later. So what I would like you to do in the remainder of the class, and I realize that, you know, so if you're watching this online, then what you should do as an exercise is to take this basic technique, adapt it your own way. You can use the notes that are in the repository as well as these patches that we've made in class, use them as inspiration, and record the output and try to compose like a 1 to 2 minute piece just by playing with some of this stuff. So you can use the key button to turn metronomes on and off. You can use random number generation and adjust the scale. Maybe you're using like only a small range or a large range. You can use mouse state or even a slider object to adjust the whether notes are happening fast or slow. You may not have that much control over, say, specific pitches, but you can control ranges of pitches. Are they high-pitched? Are they low-pitched? Are they coming fast? Are they coming slow? And by adjusting these things, see if you can make something that has a musical quality to it. You're welcome to try to do it all in one shot using quick record and just recording everything into kind of like trying to do it all from max. It's also totally valid if you want to record these pieces and then chuck them into a DAW, Audacity, Live, GarageBand, Logic, Pro Tools, Fruity Loops, whatever you have, to try to make a little composition out of it. So that's something I did earlier. So if I go to, I've got in my documents, so here are some recordings I made earlier, just little nothing pieces of piano like this. And ones like this. And I just went into Live and arranged them into a piece that, you know, let me see, this is the piece, right? So as soon as Live opens, and we can just listen to this. Oh, it's going to open in Live 12. I don't want it to open in Live 12. Don't open in, oh Lord have mercy. Oh my goodness gracious. Don't open in Live 12, please. Please open with Live 11. Thank you. So, yes, thank you. We'll just close by listening to this. So so take the rest of the time you have in class and try to arrange a piece a little bit like this. And